So this cylindrical tank looks something like this. Has a radius of 3 feet and it's 8 feet tall. And it's full of water. The water needs to be pumped out. So what we do is basically imagine here is one layer of water and it's just delta X thick. How much work would it take to get this layer of water, which would basically look like a quarter or a penny if this thing were much smaller? So take that thing and then pump it out the top. So pump it to some valve or something that's up here at the top. So that's going to have to be moved a length of X. So work is force times distance. So we've got the distance, X. Then the amount of force. Well, it depends on how much this slab of water weighs. So what we need to do is find out, for one thing, what's the volume, and the other is for water. Water weighs 62.5 pounds for every cubic foot. So if we could find out how many cubic feet this is, multiply with this, then the cubic feet would cancel, we would get just pounds. So this, let's see, is, like I say, basically like a round disc. Delta X is the height. The radius is 3. And so the volume of that thing is going to be pi r squared times the height. So the volume would be pi r squared times its height. And that means that the force is going to be 62.5 times that 9 pi delta X. And then if we take that times X, that would be force times distance, and we would have work. Then we just do that all along up and down this thing and add them all up. And that's what this is. It's a big S for sum. So sum all of these, 62.5 times 9 pi, multiply by X, and the delta X becomes dx when we integrate. And it needs to go from, well, at the bottom, X is actually a length of 8, and when it's at the top, you have a 0 distance to go. So this is going to become x squared over 2. So I need this divided by 2. So 62.5 times a 9 pi, and then that needs to be divided by 2, is that many. So we're going to have x squared. I already did the over 2, so it's 883.573. X squared is evaluated from 8 to 0. And when you put the 0 in there, it's going to be 0. Minus, when you put the 8 in there, it's going to be 64 times that number. So times 64 is that much work. So hopefully you have some kind of machine or something to do it for you, otherwise that's going to be a lot of work. And the negative is just indicating the direction that it's going out rather than in. And that would be, well, what are the units here? We've got that this is feet, and all of this was the force, which was in pounds. And so the units are foot-pounds.